All right, moving on with our geometry review in 8.3. We're working on numbers, picking up on number 8. I did number 7 last. Problem 8, using SSS similarity or SAS similarity. I think what I'm going to be using here on 8 is I'm going for an SAS because both of these triangles share angle C. So I'm going for an SAS on 8, and what I want to do is take the triangle side lengths and see if these ratios are congruent. Oh, it is. I can tell by looking at it. If I do green over, what's close to me? Green over blue and green over blue on each side. Green over blue and green over blue on each side. If those ratios are the same, that tells me that my side lengths are congruent. So green over blue, is that equal to my green over blue for the other one? Yeah, those both reduce to a half. If you pulled a math frac or whatever, these both reduce to a half. So those two pairs of sides are similar to each other. So this is the similar side, and then we need to talk about an angle in between, SAS. And in the angle in between, it's angle C is congruent to angle C. They share that, and that is the reason being reflexive property. So there's my proof of this side and this side are proportional with their angle in between congruent. That's what SAS is looking for. As long as those fractions are equal, and in this case, they were both equal to 0.5. So that supports our side angle side relationship. In number 9, I'm going to tackle number 9 in the same way. I was kind of holding off over there on tackle number 9 in the same way. I think I can talk about that angle Q. I've got the 9 related to 4.5, but in this one I've got a different, ooh, can I do SSS? Oh, I don't have an angle here, you guys, because, oh, I got all 3 side lengths. Question, this is going to be going for an SSS because I've got all 3 pairs of sides. Green to blue, green to blue, green to blue, green to blue. So then these fractions, I gotta check out all the, oh, whoa, wait a minute. I need to do the whole side length. That would be 13.5. This would be 21. So my green to blue idea isn't right. I gotta do green to yellow, the whole length. And then the 15 is the whole length over here. I got to do greens to yellows, the corresponding with that embedded thing in there. That one's interesting. Side, side, side. My question about side, side, side is going to be whether or not these are all equal ratios when I set them up. My green lengths I'm going to put on there. The 9 relates to the 13.5. My 10 on the green, the smaller one, I'm putting the smaller one on top right now, relates to the 15. And then my longest length is going to be the 14 relating to the 21. Now, I'm almost certain that these two are 2/3. I'm going to go look at my 9 divided by 13.5. That's 0.666. If you do 9 divided by 13.5 math frac, that's 2/3. 10/15 math frac, that's 2/3. 14/21 math frac, that's 2/3. This scale factor is 2/3. These guys are similar by SSS. Ooh, did I have to write a statement of similarity? I did not. Just talk about how they're similar. And this one I should have said similar by SAS. And then I'll come back to specific questions in each class. This is number 9. Why did I do 2 8s? That's number 9. Now in number 10, I'm going to come up here. You may have chosen different sides than I'm going to. I'm going to use the 2x, the BC side, related to the 32. So I'm going to color code that. I could use any 2 pairs of sides, but I'm going to use the BA, the 6, and the 24 as well. Just a reminder that we want to assume always that the first figure we see, whether it's on the top or if it's on the left, that it's the pre-image. And then the next figure we see is going to be the image. And in this one, for 10 then, let me set up yellows first. Image over pre-image. 32 over 2x should be equal to 24 over 6, my blues. You can solve this a couple different ways. I'm just choosing to do this way. 2x times 24 is 48 x's. 32 times 6 is going to be 192. And when I divide both sides by 48 to get that out of there, x is 4. The 4 would be the value of x that would make those triangles similar to each other. I think that's it for 8.3. Yep, going on to 8.4. I have already taken my 8.4 page, and for whatever reason I kept using purples and yellows. So I've taken my 8.4 page and I've got all my problems, 11, 12, 13, 14, 15, with the whole purple over yellow idea. Purple over yellow, purple over yellow. I think in one of my videos I did that. We were picking out different colors. Determine whether these guys are parallel. If our purple over yellows are congruent, then the lines are parallel for number 11. Purple over yellow is 16 over 10 equal to 28 over 20. I'm gonna go pull a math frac on both of those, or just reduce them. 16 divided by 10 is 1.6. 28 divided by 20 is 1.4. 1.6 is not equal to 1.4. These guys are not, no parallel lines. That's what we're saying here. Not that they're not similar. We can't say that this side AB is parallel to CD. Number 12, similar in that we're setting up purple over yellow is 22.5 over 13.5 equal to 20 over 12. When I go to my calculator to reduce those, I'm getting 1 2/3 for this one, and I'm getting 1 2/3 for both of them. 1.666 repeat. Oops, that's 2/3. 1 2/3 equals 1 2/3. So this would, and I know we were kind of in the habit of this in another class too. We were talking this. Then I could draw in my parallel lines. I'm going to go say it down here. AB is parallel to segment CD. Now going on to number 12 here. We got a missing length of YB. I'm going to put an X there. Number 13, missing length of YB. Purple over yellow, 7 over X. Should be equal to purple over yellow, 15 over 24. Cross multiply, 15 X's equals 7 times 24, which is 168. Is that right? And then when I divide that by 15, I get 11.2. The length of YB is 11.2. YB equals 11.2. Number 14. Bless you. You've got that bunch of 3 parallel lines. And I know the lines are parallel because there's markings here showing me that these corresponding angles are the same. So I know these lines are parallel because these markings here show me that the corresponding angles are the same. And so my lines are all parallel, which means then, let's see, what do we got? Find the length of BA. Let me put an X there. Same position, purple's over yellow. 7 over X should be equal to purple over yellow, 4 over 6. Cross multiply, 4X equals 42. When I divide 42 by 4, I get 10.5. Now 15 gets us into that angle bisector. Now remember with the angle bisector, you guys, we kind of look at the bottom being, you know, if we were to turn this around, it'd be sitting on that BC side. Purple over yellow. 4 is to 10. Wait a minute, find the length of AB. There's my X, good. 4 is to 10, purple over yellow, as X is to 18. So 10 X's equals, I think it's 72? Yeah. Divide by 10. It's cross multiplying. 4 times 18 is 72. Divide by 10. X is 7.2. So that is all. Just a reminder that your notes packets, even if you were absent, need to be completed in their entirety. If you've been absent along the way, you should have been getting the notes packet to get caught up. Notes packet you'll turn in before your test. I'll give you anything you might need posted up here on the document camera for the test. You won't use any notes for it. If you're missing any assignments, this was a short chapter, 8.1 through 8.4. If you're missing anything, you want to make sure you walk in with those. I checked in attempts on the review when you guys walked in, and I want to just say again, if you have less than 13 out of 15 done for attempts on your grade today, turn papers in that were less than 13 out of 15 so you can get some more credit back. Turn that chapter review in tomorrow when you walk in. If you have credit or 13 or 14 or more out of 15, keep it.